All right, so once you do that, if you hit the zoom and then 6 for zoom standard again, and it'll graph it. The one that we said was pretty obvious was the -4, but I'm going to show you how to find all three of these zeros. So if you hit second, and then the trace button, so the second over here and then trace, it's going to bring up options. That's calculate. And so we're looking for 0, so that's option 2. And then what you're going to do is you're going to see this little blinking star-like thing that's going to pop up. Arrow to the left until you see it somewhere down here. I think I'm too far. Where is it? It disappeared. Oh. You might not be able to actually see it where it is. So when you get to that your x, this one's not a good example because of where it is, but when you get to an x value that is, it's hard to read on here, but a little bigger than 4, since we think this one's somewhere in the ballpark of 4, you're going to hit enter, or sorry, -4, I guess. And then arrow to the right until you get somewhere to the x on the other side of 4. So mine's at like -2.3. This isn't a great problem for this. And then hit enter. So that gives you the left and right bound, and you're going to see these two little like arrows pop up. And then it says, like, basically, do you want to guess where the 0 is? And if you hit enter, it comes up and shows you that the 0 is at x equals -4. This problem's a lot harder to see it on than they usually would be. And then, let's see, we're going to try the other one and see if it's any better. So hit second, trace, 0. So if you arrow over, we know this is somewhere between 0 and -1, or at least that's where it looks like it's gonna fall. So I'm gonna come over to something a little bit bigger, or around the area of -1. So this one is gonna be on the top because left is at the top on this one, because it goes up and then it comes back down and then it goes back up again. So the left bound's gonna be the one on top this time. Right bound is going to be somewhere down over here around x equals 0. And then if you guess, it comes up and it tells you the 0 is at -0.4, and we would just need to have figured out which fraction gives you that, which would have been the 2/5 one, -2/5. Let me go back and have you put in a different one so that it's easier to see what's happening. Go back and put in the problem from 40. That way you can actually see what's supposed to be happening. That was a weird problem to do it. So in y equals, put it's x cubed plus 5x squared plus 2x minus 8. And then once you do that, graph that one. So zoom 6 for zoom standard. Yeah, so this graph is actually pretty much entirely visible to you. So this one will be a little easier to do the zeros with. So we had found the other day that they should be -4, -2, and 1. And this one's a lot easier just to see by looking at it because there weren't fractions involved. The method we were just using works, but that was kind of a weird graph for me to show you how to do it on. So hit second trace, 0. So left bound. So this graph goes, it starts down here and it goes up and then it comes back down and then it goes back up again. So when it's saying left bound, we want to be on the underside down here because it's going up first. When it asks for right bound, we're going to be somewhere up here before it turns around and goes the other way. So left bound, where I have it right now, just a little bit below the axis is good. And as long as you are somewhere on this side of it, it's not going to matter where exactly it's sitting. It's not going to change anything. Then right bound, I need to arrow to the right a little bit till I get somewhere up in this region, but it's got to be before it turns around this way. So somewhere just above, so about where I have it is good. Hit enter, then guess, and that shows you that that 0 was at -4. At x equals in. Just hit enter again, and then it'll pop up. So you don't have to use this method. I mean, when they're pretty clearly whole numbers, it's a little easier to, just guess. But when we had the problem like 44 that had a whole bunch of fraction options and I had no idea which one it could be, aside from me finding the whole number and factoring, it would have been a royal pain to try to figure out which fraction it was in there just by looking at the graph without doing some either serious zooming in or using the function to guess with. So,
how do you know, like, how far left?
I just know that it has to be before it turns around, and I basically need one on one side of the axis and one on the other. So, like, when I go to do the second one, so, like, if I did second trace to do the second one, I would need to come over because now the left side of the graph is above. So when the graph is going down like that, you need the left on the top and then the right on the bottom. And so as long as it's in this region between where it turns around, like here, it's fine. And then down here, it would just need to be anywhere in here before it turns around to go the other way again. So I could do left where I have it right now. Right, I can come all the way down here and do it if I want. It doesn't matter. Oops, nope, I just hit the wrong thing. I hit a button. Hold on. So then a 0 at -2. So as long as it's in that region, it's going to show you. And if you do like left and right backwards, it's going to get confused and it's either, I think it's going to give you an error. So then you'll just know I just need to flip them. But it's kind of just like as you go, I'm coming up from the left to get there. So then that's the right. And then I'm coming from the left to get to this one. And this is the right. And I'm coming from the left to get here. And then that would be the right. So if you did the other one, it would be left down here, right up here for that. Now, just to be clear, even though your calculator tells you that's the zeros, you would still need to show the synthetic at least for one of them to verify. But that's just kind of the method of if it's fractions and it's hard to tell, it's an easier way to find them. The one that we had as an example just wasn't a great example for that. Okay. So we had those, we found the 0, so remember, just as a quick refresher, it's whatever the last number is, the factors of that over the factors of whatever the first leading coefficient is, and then we write out all possible factors there as plus or minus synthetic, and then if we can factor after that, we factor, and this is the linear factorization. I'm trying to remember if that's the phrasing your book uses. They say factor into linear factors. A lot of times you'll hear me say factor linearization. But for the quiz test, I'm going to say what exactly the instructions in your book say so that it's not confused. So, anyways. So the few things that we had left in this section are find a polynomial function f of x of least degree having only real coefficients and zeros as given. Assume multiplicity 1 unless otherwise stated. So multiplicity is just how many times a factor occurs. So like each of these had a multiplicity of 1 because they all were raised to the first power. So all that it means is it's going to end up being like that when we're done. So let's see. 62, we have 7 minus 2i and 7 plus 2i. So there's a rule, and it may or may not have been in your notes. Oh, it is. The conjugate zeros theorem, which says that if a plus bi is a factor, then then a minus bi must also be a 0. So in this case, they gave them both to you, but sometimes the book will only give you one of them. And you need to recognize that's complex. That means that I have another 0 that's just its conjugate. So this one gave it to you, but we'll do one in a minute that they don't give you all of them, and we have to basically fill in the other one. So these are zeros, which means this is x equals 7 minus 2i and x equals 7 plus 2i. And so I need the factors, and then I'm basically going to FOIL is all that we're trying to get. We're kind of trying to do the reverse. We're starting basically at this point here in these two red circles, and we're working backwards to get up to here. But we won't be doing all the little steps in between. We'll just be going from basically here to here to here without all the middle stuff. So this means x minus 7 plus 2i is going to be one of my factors. And then x minus 7 minus 2i is going to be another factor. And so all I'm doing is taking what's in those two parentheses, and I like to say superfoil because there's extra terms in there. So we have x minus 7 plus 2i times x minus 7 minus 2i. So just working my way across, so I've got x squared, and then minus 7x minus 2ix. So I've taken care of the first x times everything in the second parentheses. So now I'm on to negative 7 times everything. So that's going to be negative 7x plus 49 plus 14i. Then I've got plus 2ix. Got minus 14i. And then minus 4i squared. Now I squared is equal to what? Yep, negative 1. Okay, so yeah, so I squared is equal to negative 1. So that means this term right here was negative 4 times negative 1. This is going to become a positive 4. Okay, because of that happening right there. Okay. So I'm just going to do this to try to not have to rewrite things so many times. So I'm going to look and see if there's anything that can cancel or anything that can be rewritten. So basically, I'm rewriting the negative 4 times I squared as positive 4. I've got a minus 2ix and a plus 2ix, so those cancel. They're going to go away and become 0. I've got plus 14i and minus 14i, so those are going to cancel. So left, I have an x squared minus 7x plus 49, and then plus 4 from that last term. I don't want to forget. So you could have gone straight to the next step without what we just wrote in the middle, but I just wanted us to make sure we can see what's left over. So our final answer then, combining like terms, is going to be x squared minus 14x plus 53. All right, any questions on that one or that type so far? I'm going to do one where they don't give us all the factors as well. Let's see. $68. 3 plus 2i, -1, and 2 are my zeros. So the -1 and the 2, those are just normal numbers, so I don't need to worry about them. But I have a 3 plus 2i, which means that by the complex conjugate theorem, I also have 3 minus 2i. So that means I have 4 total zeros. So, same way, I'm going to start these as x equals each of these things and then find the factors. This is just going to require a lot more factoring than we had in the last one. So I'm going to have x equals 3 plus 2i, x equals -1, x equals 2, and x equals 3 minus 2i. And then I'm just going to be moving all the stuff over to the left. So I'm going to have x minus 3 minus 2i, that's going to be a factor. X plus 1 is going to be a factor. X minus 2 is going to be a factor. And x minus 3 plus 2i is going to be a factor. Now, I would recommend when you set these up to actually multiply them through that you do the x minus 3 minus 2i and the x minus 3 plus 2i side by side, and then the x plus 1 and the x minus 2 side by side, because we can do two factors, like our two FOILs, simultaneously and then get that all worked out. So I would set them up like this. So basically, we'll, as I like to call it, superfoil these first two terms, and then I'm going to put like brackets around it, and then I will foil these last two terms, and then everything will get multiplied together at the end. So first things, I've got x squared minus 3x plus 2ix. Then I've got minus 3x plus 9 minus 6i. Then I've got minus 2ix plus 6i minus 4i squared. And that would all be bracketed off. I'm going to simplify it before I actually multiply because I can. But this other stuff over here, when I foil that, that's just normal foiling. I've got x squared. I've got plus x minus 2x minus 2. And so now I'm going to go through in each bracket, I'm going to try to simplify down so that when I do that final multiplication, I'm not working with something super obnoxious. So let's see. I've got in the first one a plus 2ix and a minus 2ix. So I'm going to get rid of that. I've got a minus 6i and a plus 6i, so those are going to cancel. And then I've got this negative 4i squared. I squared is negative 1, so that's going to be negative 4 times negative 1, which is going to become a positive 4. So I'm just going to go ahead and make note that that's going to become a positive 4. So I'm going to simplify this bracket really fast into x squared minus 6x, and then 9 and 4, so plus 13. And then over here in the last one, I'm going to just simplify this middle term. So I've got x squared minus x minus 2. So I'm still not done. I've got to multiply this through with a really superfoil. So I'm just going to work my way through. So it's going to be x to the 4th minus x cubed minus 2x squared minus 6x cubed plus 6x squared plus 12x plus 13x squared minus 13x and minus 26. And then now just combine like terms. So I've got x to the 4th, let's see, cube terms. I've got minus 7x cubed. Squared terms, I have 3 of them, so that's going to be, let's see, 4x, 17x squared, so plus 17x squared. And then just x terms, that's going to be minus x. And then finally the minus 26 at the end. And so this one's a little, was a little longer of a process. It had more zeros, but ultimately the process is the same. It's just the longer to get there. I want to backtrack just to show you something really fast about 64. I won't actually fully work it out. But they give us the zeros, 0, negative I, and 2 plus I. So I just want to talk about what the setup of this one would look like. So I've got 0, and a lot of times the temptation is to be like, well, it's just 0, so I'm just going to cross it out, but we can't do that, okay, because what this really means is that x equals 0. So that means that when we're all said and done, everything, the entire problem is going to get multiplied by x, because x is kind of just there by itself. I've got a minus I, which means that I also have to have plus I. I've got a 2 plus I, which means I also have to have a 2 minus I. So when I go to set this up, I basically have x equals negative I, x equals 2 plus I, x equals I, and x equals 2 minus I. So in terms of the factors that I have, I'm going to just have an x out front because x equals 0. That's nothing. I'm not moving anything over. So that's just going to be x times. I would put the things that are similar beside each other. So I'm going to have x plus I times x minus I. And then I'm going to have x minus 2 minus I and x minus 2 plus I when you go to multiply this one. And so then you would just multiply like we've been doing. This one actually might work out to be a little simpler than the one we just did just because of how it's going to play out. But I would say leave the x out front to multiply by, multiply these things, then multiply these, okay, and then go from there. So as part of your homework problems, I want you to actually finish this one. Actually, go ahead and multiply it now, and then we'll go over it, go over the answer. And then I'll give you the last few problems. I think I gave you some the other day. So try to just multiply this one out, and then we'll go over it before, so we have a lot of time left. I didn't realize where we were at with time. we got into an answer. Anyone want to share the answer they got? Or y'all just gonna wait for me to share mine?
I got x to the fifth minus 4x to the fourth plus 6x to the third minus 4x squared plus 5x.
Okay, does anybody agree with her?
I got that minus 1 exponent. So instead of like x to the fifth, I got x to the fourth.
Did you multiply by x all the way across? All right, so I held the x out front in the first step of multiplying, and then I put it in after that. So this x plus I and x minus I is actually a difference of squares, but if you didn't recognize that, all that would have happened was you would have had plus ix minus ix in the middle, which would have canceled. So I ended up with x squared minus I squared, which I squared ultimately is -1, but that was negative, so it becomes +1. And then over here, that was x squared minus 2x plus ix minus 2x plus 4 minus 2I, and then minus ix plus 2I minus I squared, which again, that's going to become a +1 here. So I canceled stuff, so that's what's crossed out in red. So the plus ix minus ix is canceled, minus 2I plus 2I canceled. And then when I rewrote stuff, I went ahead and multiplied this x through because I almost forgot about it also. So that becomes x cubed. Because this became +1, that becomes plus x. And then this stuff over here all simplified down to x squared minus 4x plus 5. And then I just superfoiled all of that to give me what's written here. And then I just only had one term I had to actually simplify to give me the x to the fifth minus 4x to the fourth plus 6x cubed minus 4x squared plus 5x. Any questions? All right, so I think I had pretty much given you problems the other day in case you wanted to start working on them over the weekend. But anyway, so I've added on 61 and 67 to what you had the other day. So what's written in green you should have already gotten. You didn't have to do it yet, but and then 61 and 67 are tacked on. So you need to have those done for tomorrow. Tomorrow we'll review for the test on Wednesday. So we'll do some review problems, kind of go back over. All that stuff kind of goes together, which is good, that we've done. So it's kind of all just like a continuation to the next step, which is nice how this is laid out. I might give you like a little like practice type quiz thing tomorrow. We'll see, since we aren't quizzing before we have a test, because obviously that's usually not the most ideal situation, but anyways, we'll see what happens with that. I might give you like a little like practice quiz, but it's not actually going to be like a quiz grade. So that way you can see if you know what you think you know and go from there.